So our star is a low mass star. The lower the mass, the longer it takes for it to fuse through all of the material that it has. Right now, the sun is an adult or a main sequence star, so it's fusing hydrogen into helium. We think it's about 4.5 billion years old. And at 10 billion, it will probably change into the next phase of the star's life, and that is a red giant. So it's going to run out of the hydrogen that it's converting into helium. And then, well, it's going to take that helium and start fusing that. And that process releases a little bit more energy. It pushes back more against gravity than just the fusion of hydrogen into helium. So helium, we're going to be going to carbon at that point, pushes back more. And the star will expand because the star stays, it has what we call a gravitational equilibrium, right? Gravity crushing in, fusion pushing out to keep that nice ball shape. So it'll start pushing out. Gravity's still crushing in, but it's not quite able to fight against it as much as it did. And as the star expands, well, the outer layers are getting farther and farther away from the core, which is the real source of that heat. So they become cooler and cooler, which is why the star looks redder and redder from the outside. That will probably extend out the boundaries of the sun to about Earth's orbit. We don't know if Earth will actually be enveloped by that, or if it'll just kind of be on the outside, or if the planet itself, if its orbit will have changed in the next, 5 or so billion years. Once it gets to the red giant stage, it's much faster, right? It goes through that fuel much, much faster than it did the hydrogen, and probably only a few hundred millions of years before it will die, before it will push off those last outer layers just out into space, and it will become what we think of as a planetary nebula. So this beautiful expanding bubble of ionized gas coming out, and dust. So when we talk about dust, we mean anything that's not hydrogen or helium. And we see really wonderful examples of this, just stunning examples of this out in space as well. But what's left at the center will be the core of the sun. Just a very, very dense, compact ball, maybe only about the size of Earth, of almost pure carbon, shining extremely bright. It has all that heat left over. It's not producing new heat, but it's got that left over.